For question 10, we're given the following information. We're asked to balance the following chemical equation and determine the number of moles of carbon dioxide produced when 4.05 times 10 to the 20 molecules of glucose react with excess oxygen to produce carbon dioxide and water. So first we should balance this equation. And the trick to balancing this equation is that oxygen appears in both the reactants. So I've got glucose C6H12O6 that reacts with oxygen and that produces carbon dioxide and water. So to balance that, let's balance the carbon first. So I have 6 carbons in glucose. I'm going to make 6 carbon dioxides. I have 12 hydrogens in glucose, so I'm going to need a 6 coefficient out here as well. 6 times 2 is 12 hydrogens. Now let's account for our oxygen. I have 6 times 2 oxygen here, right? So I've got 12 oxygen here, and I have 6 times 1 plus 6 oxygen there, a total of 18 oxygen. However, if we were to look at the oxygens on the left side of the equation, we would see that we already have 6 oxygen here in glucose. So 18 minus 6, I only need to account for 12 of those oxygen. That means I need the coefficient of 6 here. 6 times 2 is 12. 6 more in glucose already. I have 18 oxygen now on the left and the right. Now I know my coefficients for both of those. Let's see. How many moles of carbon dioxide are produced when 4.05 e to the 20 molecules react? Well, I know for every Avogadro's number of molecules, 6.02 e to the 23 molecules, right, I would have 1 mole. I can't compare molecules of glucose to molecules of carbon dioxide because of our coefficients are different. What I need to compare, though, are my molar amounts. So now that I have moles, right, I divide by Avogadro's number to determine that I have approximately 0.0006727 moles of glucose. And I want to find out how many moles of carbon dioxide are produced. Well, I would go to the balanced equation to see that for every 1 mole of glucose I put in, for every 1 mole of glucose that goes in, right, 6 moles of carbon dioxide go out. So I've got 1 mole of glucose, and that's going to produce 6 moles. So multiply that number by 6. Moles of glucose cancel out when I multiply by 6, so moles glucose cancel out, and I'm left with approximately 0.00400365 moles of CO2. Now for my significant figures, I have 3 significant figures here. I should report this number to 3 significant figures. 3 significant figures, I'm going to drop everything after the 3. I'm dropping 6, which is greater than 5, so I would round this up to 404. Put that in scientific notation. I'm going to move the decimal place 1, 2, 3. So 4.04 e to the negative 3 moles of CO2. We needed to balance that chemical equation. Once we balance the chemical equation from there, those should be steps we're very familiar with, going from molecules to moles using Avogadro's number. And then we go to the balanced chemical equation to tell us how many moles of glucose go in. 1 mole went in. How many moles of carbon dioxide should go out? 6 moles of carbon dioxide go out for every 1 mole that goes in. So we should expect to produce 4.04 e to the negative 3 moles of carbon dioxide in this reaction.